Hi everyone! Today we're going to start Chapter 5, which is all about chemical reactions. So first, let's talk about chemical equations. We've already seen a few examples of chemical equations, and they are a convenient way to represent chemical reactions. So chemical equations are written in terms of reactants and products. A symbol is written in parentheses to the right of each reactant and product to indicate the state or form in which the substance exists. So let's say you have a gas in your reaction. You're going to indicate that the molecule is a gas by putting a lowercase g in parentheses next to it. If you have a liquid, you're going to represent that with a lowercase l in parentheses. If you have a solid, you're going to represent that with a lowercase s in parentheses. And then if you have a substance that's dissolved in water, you're going to indicate that by writing a lowercase a q in parentheses. And that stands for aqueous. So down below we have an example of sugar that's originally by itself as a solid. So it's in this spoon here. So we would write the chemical formula for sugar, C12H22O11, and then put a lowercase s in parentheses next to it. And then we also have a beaker of water. So water would be represented by H2O, and it's a pure liquid, so we would put a lowercase l in parentheses next to that. Then let's say we add the sugar to the water and mix it around a bit. What kind of mixture would we have? Would we have a homogeneous mixture or a heterogeneous mixture? So if the sugar completely dissolves, we should have a homogeneous mixture. However, if some of the sugar is left on the bottom, we would have a heterogeneous mixture. So it kind of depends. We should always be specific. Now, once the sugar is dissolved in water, then we're going to write the molecular formula for sugar. And then to indicate that it's in water, we're going to put AQ in parentheses next to it. So now we know we have an aqueous solution of sugar. All right. Now, the reactants in a chemical equation are the substances that undergo a chemical change during the reaction. So remember, a while ago we talked about chemical changes versus physical changes. So reactants are written on the left side of an arrow, and that arrow is going to point towards the products. Now, if we have two or more reactants, or even two or more products, we're going to separate those by a plus sign. So as an example, down below, we have hydrogen plus oxygen, and they're reacting to form water. So you'll notice that hydrogen is a gas, oxygen is also a gas, and those are our reactants. And then they're reacting to produce a liquid. Now, the other thing that you'll notice are these coefficients. So this has to do with the law of conservation of mass. We always have to have the same number of atoms on each side of the arrow. And the way we're going to do that is by adding these coefficients in front of certain molecules. All right, and then this just goes over products. So again, products are the substances that are produced as a result of the reaction taking place, and they will be written on the right side of the arrow. And if we do have two or more products, then we'll separate those with a plus sign. Now, we do need to make sure that our chemical equations are balanced. So again, the number of atoms of each element in the reactants should be equal to the number of atoms of that same element in the products. So again, this has to do with the law of conservation of mass or matter. All right, so in this reaction, down below, we can see that initially we have 2 hydrogen atoms that are bonded together, but because we have a coefficient of 2 in front, we actually have a total of 4 hydrogen atoms. And that's on the reactant side, and we made a little table down below. So for hydrogen, we have 4 atoms. And then oxygen, we have a subscript 2, so that means we just have 2 oxygens on the reactant side. And then on the product side, we have 2 hydrogens and 1 oxygen for every molecule of water, but we have a 2 in front, so that doubles everything. So that means we have 4 hydrogens and 2 oxygens total. So everything is balanced, which is good because that means we're following the law of conservation of mass. So now how do we actually balance an equation? So let's do an example problem. In this problem, methane, CH4, is the main ingredient in natural gas. It combines with oxygen, O2, when it burns to form carbon dioxide and water. And so methane, again, is a gas, so we have a G in parentheses next to that. Oxygen is also a gas. And then on the right-hand side of the arrow, we have our products. So carbon dioxide, which is a gas. And then water, in this case, will be a gas. So we're actually forming steam. And the reason water is a gas here is because this is what's called a combustion reaction. So this is going to be really hot and really energetic. So water is not going to stay a liquid, it's going to turn into a gas. Okay, so now let's balance this equation. And we're going to start by writing out a table of what we have. So we'll write out what we have on the reactant side, and then what we have on the product side. So let's start with carbon. So on the reactant side, there's just 1 carbon, and that's in CH4. And then on the product side, we also just have 1 carbon in CO2. All right, so far everything's balanced. Let's look at hydrogen. So on the left-hand side, our reactant side, we have 4 hydrogens in CH4. And then on the product side, we just have 2 hydrogens in water. Okay, so things are no longer balanced. And then last but not least, we have oxygen. So on the left-hand side, we have 2 oxygens. And then on the right-hand side, this is where things get tricky because we have oxygen present in both products. So we have 2 oxygen atoms in CO2 and 1 oxygen atom in H2O. So that's a total of 3. Now, if you have a tricky problem like this where one of the elements is present in 2 or more products, or even 2 or more reactants, I recommend starting with the other elements first. So let's start with carbon and hydrogen, and then we'll go back to oxygen later. Okay, and then I'm just going to erase these little lines I made up above. And I'm going to choose a different color. Let's choose red. All right, so carbon is already balanced. There's 1 on each side. So let's balance hydrogen. So if we have 4 hydrogen atoms on the left, we also need 4 hydrogen atoms on the right. Now, one rule is to never change subscripts. So the subscripts in a molecule are indicating the ratio of each element within a molecule. So if we change the subscript, we're also changing the ratio of elements within a molecule, and that's going to just change the nature of the molecule. And then that's going to, or that's not going to reflect the actual reaction that's taking place. So instead, the only thing we're going to change are coefficients. So we can add a coefficient in front of a molecule in order to get the number of atoms we need, but we never change the subscripts. Okay, so if we want 4 hydrogens on the right-hand side, let's multiply H2O by 2. So we're adding a coefficient of 2 in front of H2O. And that essentially doubles everything that we have for H2O. So now we have 4 hydrogens, and we've also changed the number of oxygen atoms. So now we have 2 oxygens from CO2, and we have 2 oxygens in our doubled H2O there. So that's a total of 4 oxygens. Okay, so now let's balance our oxygen atoms. So now on the left-hand side, we have only 2 oxygen atoms, and on the right-hand side, we have 4. So in order to have 4 on each side, what should we do? So let's put a 2 in front of O2. So we're doubling the amount of oxygen that we have there. Another way you can think of it is that we're multiplying the coefficient by the subscript. So that gives us a total of 4 oxygen atoms. All right, so is everything balanced? Let's see, we have one carbon on each side, 4 hydrogens on each side, and 4 oxygens on each side. Perfect. So that means we are following the law of conservation of mass. But additionally, this tells us that CH4 has to react with 2 oxygen molecules, and then will produce 1 carbon dioxide molecule and 2 water molecules in the form of gases. So this is also giving us some information about the ratios of molecules, which we'll get into later. All right, and then here's a solution slide for later if you need it. So let's do a couple more practice problems. Let's determine if the following equations are balanced. If not, then add coefficients to balance the equations. So if you want to pause the video and try these on your own first, feel free. And then when you restart the video, we'll go over them together. Okay, so let's start with that first reaction. So I'm going to make another table. So I've got reactants versus products. All right, I'm just going to start with sodium, our first element on the left. And let's see, in the reactants, I just have 1 sodium. And in the products, I also have 1 sodium. And this is actually, let's see, Na, yeah, okay. And then let's go to oxygen. So on the left, I just have 1 oxygen. On the right, I have 1 oxygen. All right, so let's go to hydrogen next. So this is tricky. Hydrogen is actually present in both reactants. So I have a total of 2. And on the right-hand side, I also have 2 hydrogens. And then the last element is chlorine. On the left-hand side, I have 1. And on the right-hand side, I also just have 1. So it looks like everything is balanced. Perfect. So that means that 1 sodium hydroxide molecule will react with 1 hydrochloric acid molecule to produce 1 sodium chloride molecule and 1 water molecule. All right, now for the second reaction. So I'm just going to write out my table again. And if you have a different way that you like to balance equations, that's totally fine. Whatever works for you. This is just one way that I tend to do it. But as long as you end up with the right answer, then you know your method is fine. You don't have to follow the same method that I do. All right, so let's start with magnesium. So we have 1 in the reactants and 1 in the products. And then our only other element is oxygen. And we have 2 oxygens in the reactants, but only 1 in the products. So let's start by balancing oxygen, since it is not currently balanced. So what can we do to make sure that we have 2 oxygen atoms on both sides? So hopefully you said add a coefficient of 2 in front of our product. So that's changing the number of oxygens to 2, but we're also doubling the number of magnesium atoms as well. So now oxygen is balanced, but magnesium is no longer balanced. So what can we do to balance magnesium? Hopefully you said put a 2 in front of magnesium on the left. All right, so now we have 2 magnesiums on each side and 2 oxygens on each side. So now it is balanced. And this tells us that 2 magnesium atoms will react with 1 oxygen molecule to produce 2 magnesium oxide molecules. And you'll also notice that magnesium starts out as a solid, and then it reacts with a gas to produce a solid. Now you also need some heat in there too, but we'll talk about heat and energy later on. All right, and then here is the solution slide. And let's do one more equation. And this time we're dealing with some ionic compounds as well. So we might have to do something a little bit different, but we'll see. All right, so let's start with the first reaction. And again, I'm going to make a little table. So on the left-hand side, we have sodium, and we have 2 of them. On the right-hand side, we also have 2 sodium atoms. And then let's see, we have carbon next. So there's 1 on the left, and then 1 on the right. And then oxygen. We have 3 on the left. And let's see, we've got 1, 2, 3 on the right. So this is already balanced. Super easy. Okay, so in this reaction, we start with just 1 reactant, and it's actually what we call decomposing into 2 products. So we've got sodium oxide and carbon dioxide as the products. All right, now for the second equation. So we've got reactants on the left and products on the right. So starting with magnesium, it looks like we have 1 on the left and 1 on the right. And then hydrogen, we have 1 on the left And we actually have 2 hydrogens on the right. And then for chlorine, it looks like we have 1 on the left and 2 on the right. Okay, so magnesium is balanced. So let's start with hydrogen. All right, so hydrogen, we need 2 on each side. So we should probably put a 2 in front of HCl on the left. So not only does that double the number of hydrogens, but it also doubles the number of chlorines. And it looks like that's all we needed to do because now everything is balanced. All right, so hopefully that helps a little bit with understanding how to balance equations. I'll also post a practice worksheet on Canvas so you can work through some more examples. Some of the examples are a little tricky, so if you do need help with them, just let me know. And I'll also post the answer key so you can double check your answers. I'll also post some extra videos with some other examples as well so that you can kind of see a wide range. But I will see you in the next video.